circle had a center. Center had a name, O-E. So the center created, when you go to the side, was called the radius. Okay? Now, one of the first things you guys learned, even way back when, was if your radius was 4, you knew how to work a circumference. Circumference of a circle, we use the letter C. We wrote it out was 2 pi r, or pi times diameter. So if your radius is 4, what's the circumference? 8 pi. So in this case, my circumference would have been 8 pi. Okay? That's nothing new. That's stuff that I know they teach you guys from way back a long time ago as well. Okay? The new bit of that was when we started talking about this little bit that was called the arc length. The arc length was the portion of the circumference. It was, if you were walking just a bit of the circumference, how much of the circumference did you walk? Well, it dealt with the ratio of the angle. And the angle that we looked at here was called the central angle. Okay? And the central angle was made by the 2 radii that run into the arc. So, for example, if I say my central angle here is 80 degrees, and I have my radius, we'll keep it at 4. What we did was this. Our formula was the central angle over 360 times 2 pi r. So it's basically taking the circumference and multiplying it by whatever the angle is over 360. Right? Now, from there, it was just a matter of substituting the values and pressing buttons on the calculator. So the example that we used was 80 over 360 times 2 times 4 times pi. So, fraction bar, type everything through, you'd get an answer in terms of pi. This one works out cleanly. Drop those. This is 4. This is then 18. And this is 2. And this is 9. So 2 times 2 times 4 is 16. You get 16 pi over 9 would be your circumference. Again, you're using the fraction bar and pressing some buttons. All right. That was the new-ish bit that we did with arc length. And obviously, when you did this, you had to know an angle and you had to know a radius. Otherwise, it wasn't anything too crazy. When we did that last, I think it was the very beginning of last week, you guys flew right through it. There weren't too many people who were asking too many questions on it. It's just a matter of just getting used to it. Yes, sir? Absolutely. Yeah? Oh, sorry. No problem. Now, when you go through this, it's just, as you go back to circumference, a lot of times, I think those worksheet stuff that we did, what they gave you your angle, and then they darkened the circle for the portion that you're trying to find. So we did that. Those were all some CUDA sheets and everything. All right. Now, after 10.6, which we did for a couple days, we went into the 12.1. It's kind of irrelevant when we're starting looking at what section is which. It's not that big of a deal. I kind of blend everything together. That's when you start talking about what were called tangents to a circle. If you are tangent to a circle, you touch the circle at one spot. Oops. You touch the circle at one spot, and you're always perpendicular to the radius. Does that vaguely ring a bell? What happened a lot of times with that is we used it with some Pythagorean theorem, because we created right triangles. We also did some Pythagorean theorem where you had to FOIL some stuff out. Remember that? And some of the x squared stuff dropped itself through. Does that vaguely ring a bell? Kinda. Let's see if I can find that one real quick here. Let's see, that was. Oh, it's in the other one. I'm sorry, I was in the wrong. I gotta remember to reset all these things. I only have 700,000 files on the computer. What's that? Maybe not 700,000, but a lot. Anyway, I have an example here in a second. So we did that one where you wound up a lot of times with Pythagorean theorem. The other part that we did with the tangent stuff was this. If you had what was called an external tangent, if the points originated from the same spot, bless you, those guys were always congruent, bless you. Yeah, remember it made a kite. So when you had the external, it was called a common external tangent. If they still come from the same spot, they touch the circle at one spot, those segments are always the same. The math we did out of that stuff was also fairly straightforward. I don't think we did anything crazy. Okay. And like I said, I got examples of all the stuff here I'm going to give you guys. I just wanted to run through the quick little definition-ish stuff that we looked at to start with. Okay. After that, we did the interior junk, where we knew that you had what was called, if you had chords that were the same, if those two chords were the same, what did you know about their arcs? They're also the same. Okay? We knew that. We also knew that if you had a chord, if your chords were the same, they were always equidistant and perpendicular to the center. Is that vaguely ring a bell?
I think it's getting better, right?
So we did that. And again, I think with this stuff here, remember the CUDA sheet? A lot of times you guys had to draw that extra piece in. Sometimes we figured out that extra part there because it was going from the center here. It always bisected the chord if it was perpendicular, and so on and so on. When we get back to the algebra portion of it, the examples, it's easier to see as we do it all at once. What was the other word in that one? I think that was all there was in that one. We start talking about the word stuff. Oh, hello. Good morning. Would you like mine? He's not here.
Where he was going to be, that's why. Oh, wow.
All right, thank you. Try and track down this question. No problem. All right. Oh, actually, you know what?
I told you. They always do it. Get back. You said, we're hoping that you like
I'm surprised you didn't try to get there to get a problem on there right away anyway. I would have tried.
Go back outside.
I can't run back.
Yeah, there's that.
Why don't you give us that?
I get bored. It just doesn't happen. Not you guys. I just, I've got to keep you on your toes. And then the last little bit from yesterday, inscribed angles. The angle is how much of the arc that it hits. Half. If it's inscribed, if it's on the circle, it's inscribed, it's always equal to half of the arc that it hits. So you would double the angle to equal the arc, half of the arc to equal the angle. And that's just an angle symbol. It's just really, really badly drawn.
See?
You make really nice circles, man.
Singing, thank you.
Okay. What's up? What?
I watched every single one of your videos last year.
Oh, dude, I'm sorry.
Make more sense? Yeah, it's starting to make more sense.
Scary thought, isn't it? Where are you going?
No, Josh didn't. You're mean. You should. Now, you know, you need to hurry down. No, she be mean to me. No, she be not. I won't.
Oh, I swear it's never a dull moment. All right. All right, so I'm going to work kind of around a little bit on this stuff. Let's see. Let's go to 17. When I made this thing, I realized it kind of got made completely, totally out of sequence because I was just kind of like in the sequence of what stuff we've done. It's not that big of a deal.
17.
Oh. Anywho, 17 says find the arc length. It gives you an angle of 105, a radius of 6, and you see how it's shaded darker on that? Oh.
Yeah, why is it?
Huh. I didn't see it. Let's say how it ran through the machine. The machine did that. That's funny. Oh. Again, you have arc length, central angle, 105, 360, 2, 6, and a pi. When you get to that, remember, that just means you have to press buttons on said calculator. Arc length. Arc measure is always the same. Arc length is different. Okay, that's where you have to read it. That's why we say arc length versus arc measure. So you have you go 105 over, 0 over 360, and then it was what, 6 for the radius? So 2 times 6, and then remember the pi button. I know, jeez. And it'll give me an answer in terms of pi, and that's exactly what we should have. I do not need decimals. I will ask you to leave your answers in terms of pi, and that's what it does. Yeah. 17. It's stapled poorly.
There.
If it's offending you this terribly much,
Rip it off.
rip it off, and there's a stapler in the back. Help yourself. If you can't handle it, next time I'm going to staple it at the bottom left-hand corner just to make you guys all enjoy. Yeah, I should, right? I'm going to staple it. What's that? All right. That's your arc length. Circumference, remember? It sounds like circumference, that's 15 and 16. Let's try one that we have not seen in a while. Let's look at number 29. 29 is a little bit different. Oh, quit your whining. And if I drew this kind of correctly, if I drew this correctly, the angle they're giving you is here, and I think this is the one that says 39 degrees, 31 degrees. Like I said, the angle right there giving you is 31 degrees, and we're trying to find this one here. All right. So in this picture, there's a couple of things that you can take for granted. Yeah, we know that that line that touches the circle coming from the outside is tangent to the circle. So what kind of angle is formed down here? Right angle. Okay. So if this portion is 31 degrees, what has to be there? 90 minus it, which was 59. Good. Now, if you look at this picture then, you now have to work with a triangle. And you're right, there's 180 degrees in a triangle. But more specifically, what kind of a triangle is that? No. Isosceles, good. It's isosceles, and why is it isosceles? Because those are radii. Which means, what's your other base angle? Let's pick up, Gio. Okay. Let's see. 27 and 28, those are your Pythagorean theorem styles. Obviously in 27, if you just look at the triangle itself, that is the portion you're trying to solve for. That's your hypotenuse. It's really quick. 4.5 squared plus 6 squared is something squared. And then you just set that up. What's the other one?
What about number
22? So 22 is a lot like the ones we did the past couple of days. When you look at the one like number 22, and I'm pretty sure I have the sheet here. Yeah. 22. Oh, yep. Even mine's out of order. When I do 22 on this one, same idea. Is there anything on there that looks like it's a radius? I'm not sure, a diameter. Yeah. That looks like a diameter. All right. So I know that from here to here is 180 degrees. But then the other part that I know is that this angle opens up to here. So if I double that angle, what do I get from that arc? Correct. So this portion of the arc is 88. If the whole thing is 180, I just subtract it from 180, and I believe you get 92. Sounds about right. I'm back in the second page, or I'm sorry, the third page with 23 words, 23 at the top there. You look at numbers 25 and 26. Those are your external tangent ones. Okay? Your external tangent ones. Do those problems, does the 27.5 or the 26.6 have anything to do with the problem? Nope. They're there to annoy you. They are there to annoy you. So all you would have to do, since these are external tangents, those sections have to be equal. 3x and 11, 5x minus 11, okay? That kind of stuff. The extra piece inside the circle is not needed. 23, 24 are kind of the same. If we go back then to like number, let's see, 13. That's your interior cord stuff. Remember the worst case scenario for something like this? I had you guys find that exterior piece where you'd have to work with the radius and then subtract it out. Those were really easy. We guys did those as well. Here it's another Pythagorean theorem problem. Are you looking for a hypotenuse or a leg in this case? You're looking for a leg. Okay. So you have something squared plus the 15.9 squared is the 18 squared. And then it's just a whole bunch of legs. Wrong button. I'm getting the wrong button. So it was 18 squared minus the 15.9 squared square root of my answer. Rounding that to 2 decimal places, I'm getting 8.44. That's not all right. As you go through that, those guys are really straightforward. One of the things that I did not throw onto here today is I didn't put that extra Pythagorean theorem style where you had, the one where you had to find the extra piece at the end. And I didn't do the ones where we had to FOIL stuff. I figured we could knock that stuff out real quick tomorrow, plus it'd be fresher for you for Friday. So I'll have another real quick sheet tomorrow we'll look at during class. So I know it's a half day, but we'll be able to knock it out without too much of a hassle. So yeah, those four are pretty easy. Going up to like 9 and 10. 9 and 10 is when you're working with your arcs and your central angles. Now, this is when you're looking at your arc measures, like you were talking about earlier. When you're talking about arc measures, that's when you're talking about the measure of the central angle is the measure of the arc. So, for example, if I'm looking at number 9, number 9 is asking us to go ahead and find TVS. Remember, the letters tell you which way to go, so you have to go that way. All right, but it's telling me to go TVS. Well, how many degrees total are in a circle? 360. Wouldn't the easiest thing be then to just subtract out the only arc that's not part of it?
Yeah.
So what would you get? 1. Well, trust yourself. Okay. All right. Sometimes they're a lot easier than they appear. Okay. Don't forget the rules of things that appear to be diameters, in fact, are. Those first 4 that are on here, I just kind of threw those on just so you remember, because it's been a while since we did center angles with arcs. For example, if I'm looking at number 4, it says, what's the name of, if an angle is given, name the arc, if an arc is given, name its central angle. So if I'm looking at number 4, it gives us arc UWV. Arc UWV. The central angle that creates that is what? Angle's 143. Okay. It's kind of a dumb way of writing it, but it works. Same thing with number 3. It says angle 1. What arc does angle 1 run into for number 3? Usually, it's just one of those refreshers of what are you running into style things. Okay. I did not give you the page that has the solutions to this, but when I put it on the calendar today, the solutions to this will be there. You'll just have to remember that as they're not, the problem numbers aren't in order, but the solution numbers will be. So I'll have that posted up there so you can check your stuff and you can answer some leftover questions for this tomorrow. Tomorrow what we'll do is we'll do that other style problem with the, I think it was the, actually it was on the calendar, what day? We did that, it was here. Yeah. Remember when we did our first day of the 12-1, we had a couple of problems that were, find that little missing chunk. Remember that? So this one's not on your sheet, but I just want to remind you guys, how do we set this one up? Because we'll do this one tomorrow, as well as the missing little interior cord piece. We all agree that my right angle's there, correct? Correct. This portion of it is 12, okay? Now, we can do one of two things here. This is not on here, it's not on here. We can do one of two things here. I would just use Pythagorean theorem and not even worry about it, just figure out what this whole side length is. Because, and then I subtract by 12, very good. All right, that was our shortcut for that side of the problem. No. Because you look for the hypotenuse and subtract out the bit of 12, okay? So that was the style that we did, last Tuesday, I think. So it's been a little bit. We'll pull more of those together to remind ourselves of some of the little subtleties that get thrown into this. But yeah, you guys can use the time now, finish this one out. I'll have the solutions posted for you by the end of the day. Actually, I'll probably have it done over during lunch when I put it online real fast. I guess whatever.
No.
What? Do I have what? I don't. I haven't read it off yet. So I'll have it posted on there. But if you stop by the morning, you run up with it. No big deal. No big deal. I know you gotta do it, so I'm not too worried. But if you give me a second, I could probably have it printed out here for you real fast.